Well, welcome. In this video, we're going to be looking at something called conditional probability. Basically, it's looking at a probability based on certain conditions. For example, in the previous video, in the previous lesson, we looked at the situation involving the people that survived and people that died on the Titanic. Well, let's say if we were looking at that table, like it says here, if we wanted to determine the probability that a randomly selected passenger survived given the passenger was in second class. Well, the condition there is based on the fact that the person would be in second class, and that given amount is really important. For example, if I look at this table here on my left, we have that, the way that we would represent this as P given A is that we use that vertical line to represent the phrase given. And again, that portion, what we're given, is going to be in the denominator. The fact that we're looking at probability of B given A, what goes in the numerator for this particular fraction is our intersection. What do they have in common? The probability that they're both A and B. So let's look at some examples, and we're going to learn how to set up our own tables, because a lot of times they're not going to give us the tables, and we're going to have to create our own. So let's look at how we would do that and how we would use conditional probability in those circumstances. Okay, so in this example it says an article in the Journal of the American Medical Association in 1997 reported that when people go to their doctor's office with a sore throat and think they might have strep throat, 30% actually have strep throat. It noted that a current test for strep throat was 80% accurate if you have strep throat and 90% accurate if you do not. What is the probability that a person who receives a positive result from this test does not have the disease? Okay, so before we actually go and attempt this problem, we need to understand something. There are situations of what we call false positives and false negatives. A false positive would be a situation where you don't have strep throat, and you go in and you get a test done, and then the test tells you that you do when you actually don't. And that's called a false positive. It doesn't happen very often, but it does happen. And there are also situations that would be false negatives. And those also, again, although they are rare, they do happen. And those are situations where you go in and you do have strep throat, but the test tells you that you don't. So that would be a false negative. So what we're going to do first, though, is we need to set up a table. The way that we're going to set this up is we're going to have a situation where we actually do have strep. Write it like this. And we can also have a situation that we don't have strep. And in this last column, we're going to put our totals, but that'll come in the end. And then we could also have a situation where we go into the doctor and we have where we test positive, and we have where we could test negative. And again, we would have our totals down here. So setting up this table is going to help out a lot when we go and find probabilities. Let's start out with what we know. We know that it says when people go to their doctor's office with a sore throat and think they may have strep throat, 30% actually do have strep throat. So that means 30%, or 0.3, of the people that go in actually do have strep throat. And it noted that a current test for strep throat was 80% accurate if you have strep throat and 90% accurate if you do not. So what that means is that if you test positive for, so it says that it noted that it was 80% accurate if you have strep throat. So that means if you have strep throat, it's going to test positive 80% of the time. And 80% of that 0.30, so 80% of that 30% gives you 0.24. And it's also going to be, well, looking at that, we could also determine then that if it's 80% accurate, that means it's going to be inaccurate 20% of the time. So 20% of that 30% would give you 6%, or we'll use it as a decimal right now, 0.06. Now, noted that it's 90% accurate if you do not. So that means it's going to be accurate 90% of the time. So that means if you don't have strep throat, it's going to test negative, because that would be the correct way to test you, 90% of the time. Well, remember that if 30% of the people that go in actually have strep throat, that means 70% of them are not going to have strep throat. And this is going to be accurate 90% of the time, which gives you 0.63. That means 10% of the time it's going to give you a false positive. That means where you don't have strep throat and it's actually going to test out positive saying that you do. That's going to happen then 10% of the time. And 10% of that 70% would give you 0.07. And if I add up these totals, 0.24 plus 0.07 is 0.31. 0.06 plus 0.63 is 0.69. Having these columns for the totals help determine if we've done everything correctly. Because if I add both of these columns up, I should get 100%, or in this case, since we're working with decimals, I should get 1.0. And sure enough, 0.69 plus 0.31 is 1.0. 0.3 plus 0.7 is 1.0. So I can be confident that I have this correctly. Now, what is the question asking us to find? It's saying, what is the probability that a person who receives a positive test result from this test does not have the disease? So in this case, the given is that they're going to test positive. And the way that we would know that is because right here they say, what is the probability that a person who receives a positive result? So if they're given a positive result, what is the probability that they do not have the disease? So here's how you can set this up. We're looking at the probability that they don't have strep given that they test positive. So my first step is to figure out, well, what are we going to find in the numerator? The numerator is going to be the probability that they test positive and they don't have strep throat. So if they test positive and don't have strep throat, that's going to be this amount, 0.07. Over the given amount. The given amount is that they test positive. And that information is going to be, the test positive is going to be the total of 0.31. So they test positive 31% of the time, so that's what goes in the denominator, 0.31. If you divide that out, 0.07 divided by 0.31 gives you 23%. So again, let's just go over this last part again so you make sure that you know how we found that. The question is asking us, what is the probability that a person who receives a positive result? So what is the probability that we're given a positive result? What is the probability that they do not have the disease? So that numerator is going to be, again, what they have in common, where they test positive and they don't have strep. And that happens 7% of the time from our table. The denominator is going to be, what's the probability that they test positive? Well, they test positive, again, from our total, we can see that they test positive 31% of the time, or 0.31. Divide those, you get your percentage rate, or your percent chance of that happening, which would be 23%. Let's look at this one together. Here it says, let B be the possibility that a person eats a good breakfast, and let L be a person eats a good lunch. Suppose in a group of 80 people, 43 eat good breakfasts and good lunches, 21 eat a good breakfast but not a good lunch, 12 eat a good lunch but not a good breakfast, and the rest eat neither a good lunch nor a good breakfast. A lot of information there. So let's set up a table again. So this time it's going to be similar. There's going to be 3 columns and 3 rows, where our last column and our bottom row are going to be the total amounts. So let's start out with, it doesn't matter where you put this information, where you start out with. So let's say here we have that they eat a good breakfast. Well, remember, if you have a situation where you eat a good breakfast, there's going to be a flip side of that where we don't eat a good breakfast. So we'll just call that not B. And we could have a situation where we have a good lunch. And we could have a situation where we do not have a good lunch. Because again, the reason why I use L and B here is L is already representing a good lunch, and B is already representing a good breakfast. And then lastly, we're going to have our totals. That'll help us when we have to find the probabilities. Now we're going to fill in the table. For this one, it says, suppose in a group of 80 people, okay, so right off the bat, I know that there's 80 people, 43 eat good breakfasts and good lunches. So 43 would go here. 21 eat a good breakfast but not a good lunch. So where they eat a good breakfast and not a good lunch would go right here. So that's 21. 12 eat a good lunch but not a good breakfast. So that would go here. Now we can use this information to fill out the rest of our table, and we're going to use that then to find the answers to these three pieces. So we could find the total for this column. 43 plus 12 would give me 55. Means there's 55 people that eat a good lunch. And we can figure out then that, well, if there's 55 people that eat a good lunch and 80 people total, I know that there's 25 people then that don't eat a good lunch. Well, if there's supposed to be 25 people in that column, the missing piece here would be 4, because 21 plus 4 would give you 25, or I could subtract 21 from 25 to get the 4. And now I can add these rows together. 43 plus 21 give me 64. 12 plus 4 give me 16. Double check my answer here. 64 plus 16 sure enough gives me 80. So I know I filled the table out correctly. Now we want to find the probability of the intersection of B and L. That means the probability of having a good breakfast and having good lunch. Well, if there's 80 people total in our survey, and we know that there's 43 that, out of those 80 that ate a good breakfast, so 43 out of 80 gives me 53.75%. If I want to find the probability of, I'm going to do this down here, probability of L given B, well, in the numerator, we're going to have the probability of the intersection of B and L happening, divided by what the probability of our given amount would be. Well, we just said the probability, or the number of times the intersection of having a good breakfast and eating a good lunch is 43. And the probability of us eating a good breakfast was, there was a total of 64 that we can see from this table of eating a good breakfast. And 43 divided by 64 ends up giving me 0.67 or 67%. And lastly, in part C, find the probability of B given L. So again, in the numerator, we're going to have the probability of the intersection of eating a good lunch and eating a good breakfast over the probability of what we're given. In this case, the probability of what we're given is the lunch. So the probability of, again, the number of people that eat a good lunch and a good breakfast, there's 43. Out of the probability of those that ate a good lunch, well, those that ate a good lunch, there were 55 people where that happened. So the probability that they ate a good lunch, the probability that they ate a good breakfast, given that they were ate a good lunch, is 43 out of 55, which as a decimal is 0.78, or 78% would be our answer. Okay, let's look at this example, and then I'll have you guys try the last example on your own, but let's look at this one. It says, suppose all patients are tested for a serious disease that is estimated to be found in 0.5% of people. Suppose also that the test accurately spots a disease 98% of the time and accurately indicates no disease 95% of the time. What is the probability that a negative result is a false negative? Okay, so we'll get to that in a minute. Let's first create our table. Now this one again is going to have 3 rows and 3 columns. It's going to be similar to the very first example that we did, where you could have a situation where you have the disease And we could also have a situation where we don't have the disease. And then we could have our totals. Then we could have a situation, because we're going to go in, we want to figure out whether or not we have this disease, so we're going to get tested. And you could get tested positive, or you could get tested negative. And then we're going to have our totals. So now let's fill out what we know. We know that suppose all patients are tested for a serious disease that is estimated to be found in 0.5% of people. So there's a total of 0.5%. Now we have to change that to a decimal. That'll be 0.005. So we know that 0.005% of people, or 0.5% of people have the disease. We know that, suppose also that the test accurately spots the disease 98% of the time. Okay, so that means 98% of the time it accurately spots the disease. So what we would do is we would take 0.98 times 0.005, and that would tell us our answer here, which is 0.0049. Let me move these rows over a little bit. There we go. Now what that would mean is that if it's accurate 98% of the time, that means it's going to test negative when they have the disease 2% of the time. So that means 2% of the time when they have the disease, it's going to tell them that they don't, which obviously we don't want that to happen. But 0.02 times 0.005 gives us 0.0001. Now, let's read on. It says it's going to accurately indicate no disease 95% of the time. So that means 95% of the time this test is going to accurately tell us that they don't have the disease. But now remember, this disease is only found in 0.5% of people. So that means 99.5% of people don't have it. So that would be 0.995. So out of those people that don't have it, this test accurately tells them they don't have it 95% of the time. So 0.95 times 0.995 gives us 0.945. So that means it's going to be 94.5% of the people that's going to happen to. Let's look at, so now we're going to fill out this top part. Well, you could just use subtraction and figure this out. Otherwise, we could look at this as being, well, if it's accurate 95% of the time, that means 5% of the time it's not going to be accurate. 5% of the time it's going to tell us, it's going to test positive when someone really doesn't have the disease. So we take 0.05 times 0.995, and when you do that, you get 0.05 as your answer. And sure enough, if I check, 0.05 plus 0.945 is 0.995. Let's add up our totals to get this last column. 0.0049 plus 0.05 is 0.0549. 0.0001 plus 0.945 gives us 0.9451. And if I add these all together, I get exactly 1.0 in that column. And sure enough, if I add this row together, I get exactly 1.0 as well. Now, what are we trying to figure out here? We are trying to figure out what is the probability that a negative result, so that we're given a negative result, what is the probability that it's going to be a false negative? So we're given, so this is what where we're going to set it up. So what's the probability if it's a false negative given that it's a negative result? So again, what's the probability that it's a false negative given that it's a negative result? So the first step is we want to figure out, well, what's the probability of us having a negative result and it being a false negative? Now what that means is that what we're looking for is, because a false negative is when they have the disease, but the test tells them that they don't have the disease. And so that's going to happen right here. So that happens that's going to be 0.0001 out of what we're given that it's a negative result. And the test negative total is right here where we have a negative result is 0.9451. So if we divide those out, we get a 0.01% chance, because you end up getting 0.0001 approximately as your answer. So you get about 0.01% chance that the negative result is going to be a false negative. So it's not going to happen very often. Now, why don't you guys try one finally completely on your own? So why don't you pause the video, work this one out, create your own table, and pause the video and hit play when ready to check to see if you have the correct answer. Okay, let's see how you did here. So you should have set up your table like this. Now we know that there's a total of 500 passengers, or that there's 1 in 500 passengers that carry some hazardous material on them when on a plane. So when we go to set up our table, our total should be 500. Now we know that there's 1 out of 500 that carry hazardous materials. So for our total in the carry hazardous materials column, we're going to put a 1 there. And we know reading on that there is a screening device that accurately identifies 98% of the people with hazardous materials that pass through it. So we're going to have some people that screen positive and some people that screen negative. And the machine accurately screens positive 98% of those people that have the hazardous materials. So 98% or 0.98 times 1 is 0.98, obviously. Well, that means that 2% of the time it screens negative when they're actually carrying hazardous materials. So 0.02 times 1 would also be 0.02. Now if I read on, it says 99% of the people without, or it says that it accurately identifies 99% of people without hazardous materials. So people that don't carry hazardous materials with them, it accurately screens negative for those, which that means that there's 499 people that would fall into that category. So 99% of 499 is 494.01. Well, that means 1% of the time it's going to accurately screen positive on someone that doesn't carry hazardous materials. So we're going to take 0.01 times 499 is 4.99. Add our totals together and we get these amounts. Now what is it looking for? It says if a person is identified by the machine as having hazardous materials, so that's the given. Given that a person is identified by the machine as having hazardous materials, what is the probability that the person actually has these kind of hazardous materials? So again, the given amount is the fact that they're going to be screened positive, and we want to find the probability that they have hazardous materials given that they screen positive. So to start out with, to figure out, well, what is the probability of them having positive, or screening positive and having hazardous materials? Well, that is right here, where we have 98% of the time that happening. So 0.98 would be in our numerator. Well, the probability of them screening positive, our given amount, goes in the denominator. Well, that's 5.97. That goes in our denominator. So 0.98 divided by 5.97 gives you 0.164 or 16.4% of the time. Well, that's it. So hopefully you have a better understanding now how to create these tables. Sometimes setting up the tables is the most difficult part. And then once you get the table set up, know how to set up the formula for a given amount. And so hopefully now you can do these on your own. So good luck now as you work on your assignment.